Welcome to the mini pre-calculus lesson on functions and function notation. In this lesson, we're going to determine whether a relation is a function. Determine if a function is one-to-one. Use the vertical line test to identify functions. And use the horizontal line test to identify one-to-one functions. Before we get into any of that, I do want to explain what these symbols mean up here. I'm trying to help us with understanding that when you go through and do a problem, we don't just dive right into it. Unfortunately, that's where most students make their errors, and then it just gets ugly after a while. So this first symbol is just as it looks, stop, think. Think about what you're looking for. Think about what the question's asking. Because if you don't answer what the question asks, you're not going to get it right. Second one here, this is talking about, excuse me, this is talking about thinking after the thinking, what do I need to do? What mathematical process do I have to use? What information do I need to go ahead and move forward? After you do all that, you go through and you check it after you've done all the mathematical calculations here. You check to make sure, did I answer the question that was asked? Did I do the work that I was supposed to? And did I do correct arithmetic calculations? So let's start by moving into the next part of this particular video. So below is a list of the most goals scored in an NHL season and the player who scored those goals. Would the relation of player and number of goals scored be a function? Why or why not? All right, so I'm an avid hockey person. I love hockey. It's just one of those things. So if I look at this, we have to remember that this right here, this section, this is, and I'm going to apologize in advance for the handwriting with this, but this is the input. In this particular example, it's talking about the goals, so that means the season doesn't contribute anything, so we're not using this at all. Goals, well, that's going to be the output. So the output for each person would be the goals. If you know anything about hockey, you know that Wayne Gretzky is the great one. And if you don't know anything about hockey, now you do. So Wayne Gretzky, well, he had 92 goals in one season, which is crazy considering they play 82 games. So here's Wayne, he had 92 goals. Then he had another season where he had 87. If I go a little bit further, you see here, he had another season with 73 and another season with 71. You have here Brett Hull with 86. Brett Hull down here again with 72. Now, a function means that for each element in the domain, which would be this, so again, the domain is also the input. So for every element here, there should be only one element here, and this output is also known as the range. So Wayne has got 92, then Wayne also has 87, then Wayne also has 73, then Wayne also has 71. So the domain, in this particular case, the domain of Wayne Gretzky has 4 different outputs. So for every input, you should have only one output. In this case, this is not the case. It's not happening. So therefore, we know from this that this is not, not a function. Okay? Because again, too many elements of the domain going with the range. All right, so now let's take a look at this. Given these same data, would the relationship between goals and season be a function? So 92 goals, which we already know from the last one, that happened in 81-82. 87 happened in 83-84 season. So let's look our way down through here. 92, 87, 86, 85, all of those only occur once. Then we got 76 that counts 3 times. So 76 goals happened in 1970 and 1971, but then it also happened again in 92 when 2 people had 76 goals. 73, 72, 71. So now I have to look here and say, okay, for each element of the domain, is there exactly one element of the range? So I look here, I've got 76. If these two were okay, like if these two were the only two that were here, then this would be fine because they're the same number of goals and the same year. But the fact that we have two here makes this a problem. So this is, again, not a function. Okay, so just to repeat, the reason that it's not a function is because 76 has two different outputs. 76 happened in 1970, 1971, and it happened again in 92, 93. Okay. What if we reverse these elements? So I'll come back up here now. We take a look. All right, so 81, 82. Do I have anywhere else where I see 81, 82? I do not. I have 82, 83, but that's a different season. 83, 84, 90, 91, 88, 89, 70, 71, 92, 93. Oop, I got 92, 93 happening here twice. But since 92, 93 has the exact same value, that's okay. So for every element of the domain, including 92, 93, there's only one number that pairs up with it over here. 84, 85 was 73, 89, 90, that only occurs once. All right, so this one that's double goes to the exact same number, so therefore this one actually, it is a function. Okay, let's move to another example. Consider the table showing the relationship between degrees Celsius and degrees Fahrenheit. Is this relation a function? That's our first question. If it is a function, is it one-to-one? All right, so from science, we already know that we have a formula where we can go through and convert things from Celsius degrees to Fahrenheit degrees. If we take a look at this, we're looking to see, all right, so negative 10 pairs off with 14. 0 with 32, 10 with 50. I don't have any repeats here. So the fact that I have no repeats here, and that actually makes it so that we do have a function. So yes, this is a function. All right, so yes, we have a function. Now, to be one-to-one, that means that I should only have one number here, like 14 can only pair with negative 10. If I move this way to go from Celsius to Fahrenheit, then I've got to be able to do the exact same thing to go from Fahrenheit to Celsius. So negative 10 is paired with 14, and 14 is only paired with 10. 0 with 32, 32 is only with 0. All right, so it's the same concept here. So 50 goes with 10, 68 with 20, 86 with 30, 104 with 40. So therefore, yes, not only is this a function, but it's also a one-to-one function. All right, so not only is this a function, but it is also a one-to-one function. All right, so let's now take a look at what happens when there's a graph. So if we have a graph, which like we have here, given a graph of a relation, determine if this relation is a function. If it is a function, determine if it's one-to-one. All right, so I'm going to make it so I can draw lines through here. I may or may not have multiple arrows, but that's okay. So what we want to do is, we know that we can do the vertical line test to check to see if this is a function. So for a vertical line test, see if I can get this to line up nicely. And I'm going to go straight down. So there's my vertical line. Notice I only intersect at one location. If I go through and I take that same one and I move it anywhere on this, so if I grab it, oh, I guess that works. Whether I grab the picture or whether I grab the line, as I move through, notice I'm only crossing at one point. So since I'm only crossing at one point, then yes, that means that this is a function. All right, so now I can say, all right, this, yep, we got a function. Now I have to check to see if this is one-to-one. In order for me to check to see if it's one-to-one, I have to go through and grab my pen tool again, and we'll use a different color. So let's say I go to 4. Wow, that's a very large line, but who cares? All right, so now I've got the line there, and we'll grab the line this time and we'll move it up and down. So when I'm up here, I only cross at one location. As soon as I get here, I'm intersecting at more than one. More than one means that we are not one-to-one. Matter of fact, to go down this way, I've got 3, back to 2, back to 1. All I need is one example. All right, so not only is this, okay, before we knew it was a function, however, it is not one-to-one. So we've answered the questions that were asked. Okay, let's take a look then at another example. If I have a circle. All right, one of the first things you can tell on this one, all right, if I do a vertical line test, like I'm going to do right now, I'm going to go through and I'll do a vertical line test. I'll use this color. So a vertical line test, I'll start here. Oh, come on. Oops. I will come on down through. I got 2 points. So right away, this does not fit the vertical line test. If we don't pass the vertical line test, then it doesn't matter because we do not have a function. So this is not a function. No reason to check to see if it's one-to-one because it can't be one-to-one if it's not even a function to start with. Let's take a look at this creature. Given the graph of a relation, determine if the relation is a function. If it's a function, determine if it's one-to-one. This one's a little different than the other types that we've seen so far, but that doesn't matter. It's not a big deal. All right, we know that we're allowed to have graphs that just end. I mean, it's not a big deal. This one starts here, comes down through, rotates to there, and it keeps going. This one actually does stop. So this is an end point right here. All right, so that ends, but this continues. So now if I go ahead and I do a vertical line test like we did for the other ones, we'll use this one. So we'll do a vertical line test. All right, and if I decide then to go ahead and grab this line and move it side, there we go again, I grabbed the wrong one. All right, and I move it side to side, you see I only intersect once. So far we know then, okay, this is a function. So I'll give ourselves a little note here. This is a function. Let's check to see if it's one-to-one. I'll grab a different color for this. We'll go with that obnoxious large blue one. Yes, I make sound effects when I do things. So we cross here at one point. So if I grab the line again and move up and down, you see I'm only going to intersect at one point. All right, so not only is this a function, but it is 1, 2, 1. Okay? Hopefully this goes through and helps you with what we're doing so far. Again, my name is Mr. Main. I teach mathematics at Charahoe Regional High School. Later on through the year, you'll hear from Miss Leith Doucette. She'll go through and do a couple videos, but here's our first one. Thank you very much for your time.